OrthoWave is a very sophisticated outcome studies tool in clinical evaluation, namely devoted so far to hip and knee arthroplasty. As a matter of fact, OrthoWave has been designed by surgeons for surgeons about 25 years ago. Based upon all these specific do needs, we aim to set up a very enthusiastic OW2GO system mainly devoted to Asia and Pacific areas. Nowadays, in outcome studies, the master word obviously remains evidence-based medicine. As it was once said by Henrik Malkau, we need a consistent tool to compare results of all various implants. Everybody needs results, shall it be surgeons, health authorities, patients, and of course the industry. However, we are subjected to a very paradoxical situation. Surely we get fantastic computer tools. And yet, what's up with the results found in loads of published studies? We add something like 3 bananas to 5 strawberries to get what? 8 pumpkins? No, it doesn't work that way. As a matter of fact, clinical evaluation is a really huge challenge between clinical scores, questionnaires, survivorship, or registries. As a web-based outcome study tool, OrthoWave aims to meet all these expectations as a whole. We got started back in 1996 with the offline version, followed by the current cloud computing online version 6, with so far more than 100,000 hip and knee forms shared by more than 950 registered surgeons. OrthoWave features a unique and very innovative concept, encompassing 3 types of databases into one. Any regular database can be linked at will to either a scientific database or a monitored database, or even both at the same time. The regular databases are tailored for what we call regular users, feeding the database with clinical records. The first section is devoted to the so-called local administrator. This section allows for customizing the database with several tabs, with actors including users and medical staff, customizing components and keywords, setting the preferred scores and metrics, and finally, various tools including the audit trail. Aside from the administrator section, the user interface is devoted to data entry and managing results. The home page comprises patients directory, as well as statistics, imaging linked databases, and also several tools allowing to import and export records. Plus, demo tutorials are included within the Tools button. The user section displays all these various tabs as a user-friendly and sophisticated software suite, resulting in the ability to carry out all kinds of clinical outcomes. Now let's take a look at the patient form. As you can see, all demographic details are displayed, as well as all hip and knee registered surgeries, while images are also automatically linked to the patient's form. The arthroplasty window displays all related tabs, such as global details of arthroplasty, surgical details, images, as well as user-defined fields, and any kind of linked documents. Additionally, this window gives access to the clinical evaluation section. From this section, we can see that all these tabs are easily addressed upon a logical and easy-to-use navigation bar for a very intuitive and versatile learning process. Upon a similar row of tabs, all types of metrics and evaluation records can be found, and all of them allow for getting automatic scores and global table of results. A consistent follow-up of X-rays can be obtained through a map of patterns related to each type of arthroplasty and directly linked to statistics. For each joint replacement, all related images can be recorded, stored, and modified at will, allowing them to be used for a slideshow or to be exported for any publishing matter. Any image can be exported from the OrthoWave patient form to the PICTIN integrated module for any type of measurements, editing, or enhancing X-rays. And of course, all these hip features can be found upon similar display for any knee arthroplasty, be it a total or unique condylar knee. Knee follow-up, including all selected metrics, are available, including namely IKS, but also KOOS, WOMAC, or Oxford scores. In addition, all radiographic changes can be recorded, as well as various angles upon the IKS guidelines. A statistical module, namely StatWave, is integrated to OrthoWave features, including all descriptive statistics, cross-correlations, radiological maps, and survival curves. The Kaplan-Meier survivorship allows for selecting various endpoints in order to provide comparative curves and related statistical tests for any group or subgroups of cases. Call Image, another integrated module, gives access to a global imaging database. These images are linked to the related clinical records. Additionally, each image of the database can be searched, displayed, or exported for any publishing matter. Well, now let's have some words about the monitored databases, otherwise known as MDBs. These are specifically devoted to regulatory matters and monitored follow-up studies. Any MDB displays a specific tab entitled Studies, first including a subtab named Status. This status window allows for plotting all required visits, shall it be for all surgeons enrolled in the study, or any of them in particular. The second subtab, named Form, displays all details related to all registered patients, indicating for each of them the follow-up status according to each period of follow-up, labeled using a colored system. While participating in a study, any surgeon is of course willing to share his own scientific data. However, surgeons may be reluctant to let the privacy available to anybody. The OrthoWave concept aims to create virtual mirror databases as MDBs and SDBs linked to one or several regular databases, thus giving only access to the selected forms under de-identified data. We thus get three types of online databases: RDBs, SDBs, and MDBs. The RDBs are devoted to electronic data capture, otherwise known as EDC. Hence, we get several distinct databases where, in each of them, a local administrator manages several users. The scientific databases share selected data provided from several regular databases under a de-identified mode and are specifically tailored for local or national registries. The monitored databases are linked to one or several regular databases for specific implant studies and regulatory matters. As an example, we can see a MDB or SDB with its own local administrator, linked to either isolated surgeons or regular databases. Finally, thanks to these three types of databases, OrthoWave can deal with any type of clinical outcome in orthopedics. In order to sum up these various links between databases, the following diagram shows any potential relationship and interconnections between the various regular databases, be they or not linked to one or several distinct scientific or monitored databases. We have now addressed the various features offered by OrthoWave. Yet, at the end of the day, who does what with this outcome study tool? Well, first, the surgeon collects data. Secondly, local registries can be set up from groups of surgeons through regular or scientific databases. Third, comprehensive brand registries gather thousands of cases, which would be soon available from scientific and monitored databases. And last but not least, we might easily anticipate on global registries, be they regional or national as a sound and efficient means of evaluation of implants outcomes on a very large scale. These global registries would be linked at will to loads and loads of regular databases from any selected area. Thanks to its very up-to-date secured cloud computing features, OrthoWave can be addressed from any internet-based unit, be it a regular computer, a laptop, a tablet, or even a smartphone. If you were to require any additional information, we will be delighted to get in touch with you on the OrthoWave website at www.orthowave.net. 2016 will introduce a new era and a very exciting challenge for us, which is to bring OrthoWave to Asia and the Pacific area with this OW2GO project. Finally, the OrthoWave team thanks you very much for your attention, and if you're willing to be OrthoWaved, it will be our great pleasure to show you how to go.